Hey guys, my name is Shreyas and welcome to the first video within our stoichiometry unit. In this video we're going to be talking about how we balance chemical reactions. So let's look at this equation here. So now remember back to the law of conservation of mass. That says that in any chemical reaction the number of atoms you start out with has to equal the number of atoms you end up with. So if you look here in this chemical equation, let's count the number of atoms of each element on both the reactants and the product side. So on the reactant side, we have one carbon atom, we have 4 hydrogen atoms, and then we have 2 oxygen atoms. On the product side, we have one carbon atom, we have 3 oxygen atoms, because 2 plus 1 is 3, and then we have 2 hydrogen atoms. So this is not matching up. So because of that, we're going to have to balance the chemical equation here. So let me go ahead and write this chemical equation out again. Okay. So what we do is the best strategy is to focus on the most complex molecule or compound, which is the one with the most atoms. So this molecule right here seems to have the most number of atoms because it has 5. Nothing else compares to that. So let's start here. So we have one carbon atom here, and we have one carbon atom here. That's good. We have 4 hydrogen atoms here, and we only have 2 here. So what we could do is we can put a coefficient here, 2, and now we have 4 hydrogen atoms here. Now on this side of the chemical equation, we have 2 plus 2 times 1 is 2, 4 oxygen atoms, and here we only have 2, so you can just put a coefficient of 2 here, and then everything is balanced out. Let's check. So 1 carbon atom here, 1 carbon atom here, 4 hydrogen atoms here, 2 times 2, 4 hydrogen atoms here, 2 times 2, 4 oxygen atoms here, 2 plus 2 times 1, 4 oxygen atoms here, and now the equation is balanced. Okay, let's go ahead and do a few more. So in this chemical equation, let me write this out bigger again, so I don't have to squeeze the coefficients. Alright, so in here we're going to have to focus on this compound right here, because it's the most complex one. So let's start with the magnesium. So there's 3 magnesium atoms right here, and there's only 1. So we can put a coefficient of 3 here, and now the magnesium atoms are balanced out. The phosphorus, there's an invisible 1 here, times 2. Again, this is a review just to get to know the number of atoms within a compound, and you have this parentheses here. You're going to look at the inside subscript and then multiply it with the outside subscript, and that's how you know the number of atoms. So here there's 1, even though we don't write it, there's still a 1 here. So 1 times 2, so that's 2 phosphorus atoms here, and there's only 1 phosphorus atom here, so we can put a coefficient of 2 here. Okay. Now the problem here is that we have an oxygen atom here, and we also have oxygen atoms here. So it gets a little complicated trying to balance it out. However, we only have hydrogen within this atom right here. So what we can do here is just count the number of hydrogen atoms here, and then try to balance that out with the number of hydrogen atoms here, and then we'll come back to looking at oxygen. So here we have 1 times 2 is 2, times 3, 6 hydrogen atoms, plus 2 times 3 is 6, which gives us a total of 12 hydrogen atoms. Here we only have 2, so if we put a coefficient of 6 here, we also have 12 hydrogen atoms. Now, let's see if the oxygen atoms are balanced out. So we have 6 times 1 is 6, plus 4 times 2 is 8, that's a total of 14 oxygen atoms. Here we have 1 times 2 is 2, times 3 is 6, plus 2 times 4 is 8, 14 oxygen atoms, and now everything is balanced out. Okay, let's do this. Alright, so again, focus on the most complex molecule. That's definitely this one right here. So there's 12 carbon atoms here, and there's only 1 here. So we can put a coefficient of 12 here to balance that out. Here there's 22 hydrogen atoms, here there's only 2. So we can put a coefficient of 11 here to balance that out. Now, let's look at the oxygen atoms. It's a little tricky. We have 12 times 2 is 24, plus 11 So that's 35 oxygen atoms here. Here we have 11 plus 2, that's only 13. So what we could do is, since there's 11 here and there's 11 here, we can ignore that. And then we have 24 here. So maybe if you put a 12 here, we can get 24 here as well. So let's look at that. So now we have 11 plus 12 times 2 is 24, equals total 35 oxygen atoms. And here we have 12 times 2 is 24, plus 11, 35 oxygen atoms. And now, great, everything is balanced. Okay. Let's do one final one, and then you can go and practice this on your own. Here, we don't really see a atom which is more complex than another. So let's just go ahead and try to balance each element out on its own. So here we have one nitrogen atom, here we have one nitrogen atom, great. Here we have 3 hydrogen atoms, and here we have 2. So what we could do is maybe put a 3 here and a 2 here, and it balances out. I just flipped the numbers here. So we have 3 times 2 is 6 hydrogen atoms here, and then here we have 2 times 3 is 6 hydrogen atoms here. Now because of that, we have 2 nitrogen atoms here, so that means there's going to have to be 2 nitrogen atoms here. Okay. And now let's look at the oxygen atoms. So we have 2 times 1 is 2, plus 3 is 5 oxygen atoms here, and oh no, we have only 2 here, but we can't put 2.5 here because it has to be a whole number. We can't just put 2.5 times 2 to get a 5 here. However, 2.5 is also 5 over 2. What we can do is we can multiply this whole equation by 2, multiply all the coefficients by 2, and then we can get this would turn into a 4, this would turn into a 5, so now we have a whole number here. This would turn into a 4, and then this would turn into a 6. Okay, and now everything is balanced. Let's look. Nitrogen atoms here, 4 times 1 is 4, and here we have 4 times 1 is 4. Hydrogen atoms, 4 times 3 is 12, 6 times 2 is 12. And here we have 5 times 2 is 10, here we have 4 times 1 is 4, plus 6 times 1 is 6, add that together we have 10. So now everything is balanced out. So what you could do is, like, the strategy I used here is that sometimes when we get a decimal like that, I just put in the decimal and then multiply the whole equation together to get rid of that that fraction or decimal, and then everything is balanced out. So the equation would be 4NH3 plus 5O2 yields 4NO plus 6H2O. Okay, so this is a little bit tricky, and it's something you just have to develop on your own. But I hope this video helped. I used a few strategies here that could help you balance chemical equations. But that's basically how you balance equations. Make sure you practice this because it's very important to know how to balance chemical equations. But it's as simple as that.